Class, this is going to help with videos, going to help with 10-2 in business calc, and we're doing the derivative of the logs. So the first section in this, you're kind of reviewing some of those interest formulas, compound interest and continuous interest. Now we're going to look at the derivative. Okay, so the first thing is the derivative of e to the x, by far the easiest thing ever. If I have a function, e to the x, then the derivative is e to the x. Okay, another way to write that, remember we can write it as d dx of this, okay, is e to the x. So notation, just kind of trying to show you a couple of them there. So you got to remember that you don't do anything like subtracting on your exponent or anything like that. Okay, derivative of e to the x, e to the x. Now, if you have e to a number, that is different. That's not e to the x. That's a number. You can put it in your calculator and get a number. The derivative of any number is 0. So they try to trick you on a couple on your homework. Okay, next thing. What if I have something to the power of x? So this example is b to the power of x. How would I take the derivative of that? Okay, could be 3 to the x. It could be 10 to the x, anything. B could be anything. If I have that x in the exponent, then you keep what you have. So I keep b to the x, and I add in the natural log of the base. Okay, same with the notation here, d dx of this is this. And you could do dy dx, but it's written a little bit different, not right next to it. If you have the y, then you don't have the formula as close, but that's another notation. Okay, what if I want to take the derivative of a natural log? So I have natural log of x. If I want the derivative of that, it's 1 over x. Okay? So the derivative is 1 over x. And the x part has to be x. If it has more things with it, then we need a rule we're going to be doing in a couple sections. Okay, so that'll be coming. What if I have the log, base b, whatever our base is, right, of x? Not natural log, but the log. Then I would have 1 over the natural log of the base times 1 over x. So you have to bring in that natural log of the base. Now this could be written with the x in front. So if you Googled this concept, you'd probably see that x in front. But I wanted you to see it, well, this is the way our book writes it as well. And I wanted you to see it and think of it as, well, this is the natural log part, and then that's taking care of the fact that your base isn't e, right? Because a natural log is a log base e. There you go. All right. So let's look at some examples. So my first example would be if I have f of x equal to 5e to the x minus 3x to the fourth plus 9x plus 16. So if I have something like this and it says, what's your derivative? Okay. So what is the derivative of this function? Well, we already know we can do the derivative of each thing with the plus and minus, so we're going to look at each one individually. So what is the derivative of 5e to the x? Well, we also know we keep the constant out front, and the derivative of e to the x is e to the x. So this one will stay 5e to the x. Okay, so then the next term doesn't have a log or anything, so we're just going to bring down that exponent, and 4 times negative 3 is negative 12. X to the third, lose 1 there. Derivative of 9x will be 9. Derivative of 16 will be 0. So there you go. Okay, what if So I liked this one because it's kind of tricking you. I mean, I shouldn't say I like it because I don't really like tricky questions, but this is not e to the x, it's x to the e. So what is e? E is a number, like pi. It's like goes on forever, 2.7 something. So really e is a number. So if we have something with e in the exponent, we follow our exponent rules to do our derivative. So we keep the -7 out front, and then for our e, we're going to subtract 1 from here and then times the e by what's in front. So I'm going to times that by e, and then I'm going to subtract 1 off e. All right, I think that might be in your homework, which is why it's in my notes, but a little bit tricky. Let's look at a couple more. What if I say g of x is equal to 2 to the x minus log base 4 of x to the 5th. Ew. First of all, I probably should have done a couple more. It's fine. I should have probably done just this one alone. First of all, what can I do with an exponent on a log? Because I can't do the derivative right now if that's not just an x. So what is the rules that we learned in algebra that allow us, or what do we do with that 5? We can bring it up front. So first thing I want you to recognize is this needs to go out front. So I'm going to change this to be 2 to the x minus 5 log base 4 of x. Now I can follow my rules. So we always have all these things that we have to do to make it to where we can do our shortcuts. Or goodness, you could try to do that 4-step process with the limit. Okay, so what do we do from here? Now we're going to do our derivative of each one. So what did we say that we could do for something with the exponent being x? We said the derivative is keep what you have times the log, natural log of 2. That's it. So we got the derivative of the first one. Now, we know it's a minus in between. We keep the 5 out front because any constant we just keep and then times by the derivative as well. So we're good there. And then what did we do with our log is we did it as 1. So we're going to times this 5 by 1 over natural log of the base on the log, which is 4. And then we had to times that by 1 over x. So what's another way to write this? You have to think of this as like a parenthesis. You could probably type this into my math lab just like this if you have a parenthesis around that, and it would work. But I want you to think about this part. I could write this, the first part stays the same, as 5 over x times natural log of 4. If you write it natural log of 4x, then you have to use a parenthesis around the natural log of 4, or they'll count it wrong because it'll look like it's 4x. And it's not. The x is separate. Okay, done. Getting a little harder. Okay, that's our derivative there. Okay, what if we have something like f of x is equal to -1 plus 2 natural log of x, and you want to find the equation of the tangent line at x equals 1. So maybe, well, that's okay. Oh, make that piece bigger. Where my thing is, I just can't quite fit the paper there. There we go. Okay, so if we have this and we want to know, find the equation of the tangent line. At x equals 1. So we have to have that x equals 1. Oh goodness, what did I do for this again? It's going to be in every section. Oh, and on the final and on your exams. How do I find the equation of a tangent line? Well, I take the derivative, put my number in, and I get the slope. Put my number into the original, and I get my point. And then I use point slope to get my equation. So let's do that. So to get our slope, we then take the derivative at that value 1. And for our point, we then put in that 1 back into our original function, just for your notes there. So we need to take the derivative of this. So what's the derivative of our function? Well, -1 becomes 0. So that's gone. We keep this 2, and the derivative of natural log of x is 1 over x. So we're going to have 2 times 1 over x, or it could be written as 2 over x. Okay, so simplified. This is fine. Doesn't matter to me. So then let me go ahead and move that off. Here is our function. So let's put in that value 1, and we would have 2 over 1 or 2. So my slope, or m, is 2. All right, now if we want to find our point, we go back to the original. So f of 1 is going to look like -1 plus 2 natural log of the 1, putting that value in. And what does this one end up being? Doesn't it have a natural log in it, or does it work out pretty? Natural log of 1. So sometimes they don't work out super pretty. So I was just checking my notes. What is the natural log of 1? Isn't it 0? Yep. So the natural log of 1 is 0. Why I forgot, I don't know. 0 times 2 is 0 plus -1. We're actually going to end up with this equaling -1. Now, at this spot, you could have it be a natural log number. Like I could have ended up with like 2 natural log 4, and you would have to finish the problem with natural logs in it. So we got a pretty number here, so our point is 1, -1. Some of yours all have pretty numbers and some don't. So then we say y minus y, which is -1, equals slope of 2 times x minus x. Okay, done. Got our equation, but let's simplify. This would be y plus 1 equals 2 times x is 2x. 2 times 1 is 2. Okay, and then we subtract the 1 over, and I'd have y equals 2x minus 3. And that's my equation of my line in slope-intercept form. All right, what if, I have one I want to show you in Desmos. Let me check. I think that will be good after this one. I think this is my 5th question. What if I have e to the x over 4, and I have g of x is equal to x squared? What if it asks, where do these two intersect? If we have two functions and we want to find where they intersect, it specifically says use technology. So go ahead and we'll use technology. I'm going to go ahead and use Desmos just because it's easy for you to see. You can use your graphing calculator as well. You plug them into the y equals. You graph. You have to see on the graph where they cross on a graphing calculator in order for it to tell you where they cross. So know that. Okay, so if I put this in here, now if you do these problems and you get a decimal, that is maybe they ask for 0.41 and you put in 0.4, or they ask for 3 decimals and you only got 2 on your calculator, just use the ask the instructor button if you're correct, but it counted you wrong. So let's put in our first function. We said e, and if you just type in the e like on your screen, it'll know. So we had e to the x divided by 4, and we had the function x squared. Perfect. This is where they are, and they cross in two places, here and here. Ooh, and then they cross again. I would have almost missed that. Yeah, they cross again. And in Desmos, if you just kind of scroll it around the cross, it'll tell you the point. So there's the third point. So if you're looking for intersection of two functions using a graphing calculator, I love Desmos because it's really easy to see. And I can like scroll in and out super easy and see where they cross. So there you go. There's an example of that. So what are we doing in this section? We're taking the derivative of those logs. You're still going to be applying a little bit of the um, um, finding the equation of the tangent line and things that we do with derivatives in this section as well. You can also find the rate of depression. What's a rate? It's the slope. So you might be asked a couple things that have different words for slope. All right. See you later.